All right, dude, we are live. What's up, guys? This is Dem Keys, and I'm hoping we are live. I just need to check and confirm because I have had to restart OBS like 4 or 5 times now. Each time I would open it up, this pop-up would come up saying something about failing to load Twitch data, failing to connect to Twitch, or something to do with the um, connecting to Twitch or authenticating with Twitch. I'm not sure. And I assumed that that meant that I needed to restart OBS. But then just now, despite getting that dialogue again, I decided to click start streaming anyways. And it seems to have started streaming. So I'm not sure. Yeah, okay, even on my phone, it's saying that I'm live. You know what? Okay, this was a weird intro. So we're gonna restart that. Um, what's up, guys? This is Dem Keys, and today we are gonna continue learning about the ESP32 and ESP32 Rust programming. We're gonna focus on, or continue focusing on. Hey, give me a second. I'm not seeing a video feed. Oh, there it is. Okay. For a second, I was gonna be like, oh, hold on, I'm not seeing a video feed on my phone. So like, what's going on there? But yeah, no. We are live. I think I'm just having some bandwidth issues. Let me see if I'm able to. Holy shit, this is a weird start to today's stream. Anyways, I mean, we're live now. Let me just confirm that we are good in terms of lag. Oh, wait. Yeah, forgot about that. Um, okay, so yeah, we're good. Okay, all right. So we're gonna continue learning about how PWM and just clocks in general on the ESP32 work, how this ticking mechanism works, how the ESP32 counts time. Let's say it that way. It's been an interesting subject to get into. Between yesterday and today, I made a lot more. Well, I did a lot more research. I was about to say I made a lot more progress. I kind of made more progress, but like it wasn't necessarily in the clocks section. Um, Also, yeah, I should definitely be doing more research in terms of like in terms of how things work because holy shit, dude, I had like a major misconception of how the clocks work because like I was assuming that so we have the APB clock, which is what the PWM hardware reads from. And I was assuming that the crystal oscillator feeds a signal directly into the APB clock, and in between there's some sort of hardware that multiplies this signal or maybe divides the signal depending on what speed it's coming in at. But it turns out that's not the case. It turns out that um, you have the crystal oscillator. It it puts out a 40 megahertz signal. It puts out a signal at a frequency of 40 megahertz. And then there's something called the PPL, or was it the PLL? It was a phase lock loop. PLL, sorry, not PPL. Um, there's something called a PLL, which effectively multiplies this to make the signal bigger. So it makes the signal, I don't remember what it was, maybe 400 something. Yeah, something along those lines. It makes it 400 something, 480 maybe, 480 megahertz. So we've gone from 40 megahertz up to 480 megahertz. Let's assume it's 480. And then from the PLL, this clock signal is consumed by the CPU clock, but because 480 is a very high speed, so what the CPU does is it divides it down to I don't know 240 or 160 or something like that, just so that the clock speed is kind of low, and among other reasons, it's also consuming less power. So this clock speed gets dialed down to or divided down to say 160 or 240 megahertz, and then from the CPU clock it goes down to the APB clock, where it gets further divided down to 80 megahertz. And then from the APB clock, it gets used by the PWM hardware, which at this point, considering that I got the APB clock thing wrong, I'm wondering if there's some information I'm missing, or rather, I should say, considering that I was missing information about how the APB clock gets its signal, am I also missing information about how the PWM hardware is getting the signal? Like, could there be something in between this as well that I don't know about? I think I should find that out. And I feel like this um, further highlights the importance of reading the what do you call it? The technical specification of the ESP32. Like the technical the reading the not the specs, but it's like a data sheet. It's I think yeah I think technical details basically. It's important to read the technical details of this device. At least for me, I'm seeing the importance of reading the technical details of this device, because this is what would be giving me this information that, yeah, the signal is coming from this source, it's going to that source, and so and so thing is happening, and from here it goes there, and all of that. Okay, all right. So we are getting close to finishing um, understanding how these signals are used. We came pretty close yesterday. Hold on. There was um, this thing. This specific thing, I need to keep reminding myself about it. Um, I actually didn't look at this after yesterday's stream. I was supposed to look at this after yesterday's stream, but I didn't do that. Um, yeah. So I was supposed to look into this after yesterday's stream, but I didn't really do that. Um, I got busy with other stuff. Actually, I've been doing a bunch of research between yesterday and today. Real quick, I want to show you guys ESA. This is it's a more modern LS. So with LS, you have this. It gives you output in various ways. You're not limited to just that. Like for example, LSAL, you get this kind of output. Similar to LS, you have ESA, and in I believe in ESA also you have this. Yeah. So you can get similar information. I am yet to do research on all of the features that ESA provides, but I wanted to, you know, give this a try. And I also like the fact that, there's the whole color coding thing going on. And um, because I like Rust so much, so that's another reason why I was attracted to this tool, because this is a Rust-based tool. There's another tool that I wanna look into. The thing is, I don't often use that feature. I'm not in too many situations, at least right now, I'm not in too many situations where I need to do a hex dump. Generally, if I need to look at the contents of something, I mean, there are a few situations where I need to do a hex dump, and then, well, we do have hex dump. Um, oh, this is waiting for input. Let me give it a file. What are we in? Okay, hexdump C, because you can do you can get the hexdump in different formats. It's a very versatile tool. Source main.rs. So this is the hexdump. I'm not in too many situations these days where I need to do a hex dump, but there are a few situations, and I'm pretty sure once I start doing more low-level stuff on like the ESP32, for example, there will be situations where I need to, look at byte-level data. Also, maybe when I'm storing things like in byte format, in binary format, I might need to look at the hex dump. Um, but yeah, okay, so we have hex dump, right? There's a Rust-based tool called Hexel. I wanted to give that a try, um, but like not just yet, not right now. I don't necessarily need it right now. Okay, so let's talk about what I've been up to between yesterday's stream and today's stream. Okay, I was having a bunch of different conversations with Gemini. One of them was this one that I believe I was having this on stream. This was about the capacitive touch and the force sensitive resistors and 2D positional tracking and stuff like that. Um, you know what? For the time being, I think I can let go of this. I'm not entirely sure I even want the force. Actually, I might. No, 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 no. I might want that. Yeah, yeah. I might want that. I might want that. Yes. Because for robotics, because there's very I was having another conversation with Gemini about which components I would require, which components or sensors I would require for robotics related stuff. Because with robotics, you have these devices that are communicating with the outside world. So sometimes you have the necessity for touch or push or maybe sensing light or sensing heat or anything like that. Stuff that communicates and interacts with the outside world, with the surrounding elements, with the physical world. um, so I wanted to try and get a bunch of different sensors cheap because I don't have too much money to spend on this, but still sensors to a certain extent. I wanted to try and get whatever I can. One thing I should take into account about force sensitive resistors is these are meant to be pushed mechanically. Like there's some amount of like mechanical force that has to be applied to it. And that means that they are probably going to go bad after a while. So maybe maybe it's better for me to spend money on like smaller versions of these FSRs, and then as they keep going bad, I can keep replacing them. Okay, so for now I can close this conversation. Um, Another conversation I was having. So I was talking to Gemini about this. I think I'd mentioned this yesterday. I was talking to Gemini about like, okay, let's say I'm working on a robot, right? I'm building this robot. The robot has a bunch of different things attached to it. Um, it has two DC motors, and to control those DC motors, it has a DC motor module that has to receive external power, not power from the ESP32. Okay, so that's one thing. Another thing is we have two servo motors which are being controlled by a servo motor, a servo driver module. This module also requires external power. You can't or you shouldn't be powering it through the ESP32. They have like dedicated terminals for you to feed in external power. Okay, great. Then we have a TFT display which is going to be connected to the microcontroller. Even the modules will also be connected to the microcontroller. And then maybe a couple extra things like buttons and stuff like that. Maybe there might be a piezoelectric buzzer or diaphragm. I'll see what else I want to put in there. Maybe there might be sensors and stuff. But the point there was we have all of these things connected to the ESP32, right? Keeping everything else aside, specifically the DC driver module and the servo driver module, both of these are going to be pulling an insane amount of current. So we want to feed power into this from we want to feed power into this from the um, we want to feed power into this externally from a dedicated power source. So my idea there was to use a USB breakout board and split the output of it. So the plus and the minus, the VCC and ground. We split the plus into the ESP32, the servo driver, and the DC motor driver. Right. My concern there was what would happen if I need to debug this ESP32, because the robot is going to have a program running on it, right? I have to develop the program while I'm developing the circuit. And what was I saying? Yeah, I have to develop the program while I'm developing the circuit, and there's going to be a bunch of debugging happening. Whenever there's a new version, I have to update the program. For all of these reasons, this ESP32 has to be plugged into um, it has to be plugged into the computer. My concern was, as soon as I plug it into the computer and these things start running, they're going to pull current directly from the USB port of the computer, and best case scenario, the computer reboots because of over current protection. Worst case scenario, it fries the port, which would be horrible. So I wanted to avoid having those kinds of situations. Um, so I was asking Gemini what's the best way to go about this. After getting a bunch of ideas from Gemini, something that I remembered was, okay, I'm currently programming these microcontrollers using the USB port, right? But the microcontrollers are not limited to just using the USB port. I could use, um, I forgot what they're called. You have these devices, these dedicated devices that do flashing and debugging. So you can use them to flash a binary onto the ESP32 by hooking up that device. So the device on one end it's USB, and on the other end there's a bunch of exposed pins. Those pins have to be connected to specific pins on your ESP32, and that's how you can flash the ESP32. That's how you can flash the binary onto the ESP32. And then for debugging, there's a similar workflow as well. I haven't looked too much into that, but there is something similar for debugging, and you can use that exact same device for both flashing and debugging. So I was like, okay, what if I try doing that instead? What if I start using that method instead of flashing the binary onto the ESP32 through the USB port? Um, that requires me to first of all buy the device. The device, fortunately, it's not going to be that expensive, and also there's a more general purpose device as well. So one device is called ESP-Prog. That's the device that you can use for, I'm assuming, both flashing and debugging ESP32 devices. But there's also a more general purpose one. And the other day, one of the people in the chat had mentioned this as well. And yesterday, when I was looking into it, when I was looking into, various like ESP32 flashing utilities, then that same device came up, and that happens to be a more general purpose device, but it's cheaper. So I need to see how well that works. Because I mean, I'm mainly dealing with ESP32s right now, so I don't mind using an ESP32 specific device, or an ESP32 specific programming utility. I'm not going to be buying it right now though, because I'm not quite yet there. I'm not at that point yet where I absolutely need this programming device. It would be good to have it though, because the debugging capabilities would be very helpful, especially for embedded programs. Knowing exactly what is going on in the microcontroller, because like with the debugging utility, it can it'll allow me to essentially pause the the CPU's execution right where it is and examine the entire CPU, or well, certain parts of the CPU, to see, different variable values and stuff like that. Um, so yeah, I might need to do some research into that as well at a later time. Another thing I was discussing with Gemini. Dude, I'm so glad that I never did this ground sharing thing when it comes to like combining circuits, because and yo, each time I mention optocouplers, I can't help but shout out Ellie Minibot, because it's thanks to her that I found out about optocouplers. She was uh she was doing a stream where she was hacking some sort of game controller. I don't remember what kind. Maybe it was like one of those generic game controllers that you can connect to the PC or something. I don't remember. But she was hacking one of those to be able to control. I think she was working on a robot. Um, I think it might have been something to do with the Neurosama robot that they were working on. I don't remember. Either way, she was doing a stream where she was hacking this this controller, and that's where she had mentioned optocouplers, and she was explaining that, yeah, these are optocouplers. These allow you to control the control this circuit from another circuit while providing isolation between the two. And that day I looked it up and I was like, oh my god, dude, this is exactly what I need to be able to hack circuits. I've been in the past, whenever I wanted to hack a circuit and control it using an ESP32, each time that I looked up the information online, it would the majority of the time, the most common reply that I would get is use a transistor. There were also other replies like relays, for example, but like a relay is meant for other purposes. It's not necessarily meant for, sending a signal each time. Or sorry, it's not necessarily the best thing to use when you will be sending signals often, because with relays, they actually have like some mechanical action going on in there. And that's why each time when the relay is switched on, you're going to hear like a physical click or something like that. Um, what was I saying? Oh yeah. So because of my lack of more advanced analog electronics knowledge, I was never comfortable with just joining two circuits together. I never fully even understood how the science works there, in terms of like the flow of electricity. That's also one of the things and that's a more basic thing, right? Like how the electricity is flowing, what it's flowing through, what paths it's taking. I've heard it commonly mentioned that it takes the path of least resistance, and that kind of helps, but not necessarily always. That being said, this was one of the many reasons why I wasn't comfortable with just joining two circuits together. Two circuits being the ESP32 circuit and the whatever other higher power device I was trying to control through the ESP32. I was never comfortable with joining them together because if you're going to be using a transistor to allow you to control the high power circuit from the ESP32, at some point you have to share the ground between them, and that is where I was very, very unsure about, you know, whether it's a good idea to do that or not. And so I never did it. And then once I learned about optos, then I did research and I realized that, yo, this is exactly what I've been looking for. Give me a second. Let me load up the, yeah, there it is. So, um, yeah. Shout out Ellie Minibot, because of whom I know about optocouplers now, and I'm definitely going to be using them in a lot of different circuits that I'm planning on both building and hacking. Now, because summer is coming, I do also need to place an order for some ultrasonic. What do you call them? Atomizers. Yeah, they're essentially, in a way, misting modules. In a way, misting modules. They they're these cheap, um I forgot what those things are called, but like it, in a way, they're also diaphragms. You basically place them on like a surface of water, and from the other end, like once the module does its thing and uh, gives it signals at very high frequency, then it's gonna vibrate rapidly and then produce this sort of mist. And what's the other word that I was planning on using? So there was mist, and there was, so okay, atomizer, mister, humidifier. That's another thing. Dehumidifier. No, humidifier. It's not dehumidifier. I think it's a humidifier because yeah, that's another thing. This mist that's produced, or this what do you even call this thing? Is mist the right word to? I'm using it as a mister. I wanted to create a mister, but like the mister itself, it requires much more higher pressure and stuff, so it's not gonna work out because the hardware that I need to get for that, um it's just not gonna work out. So the next best solution was to create these, essentially this vapor kind of thing. um there's a specific word to use for that, but it's basically when like you have this water being vaporized and or atomized, and it becomes like this white smoke sort of thing, but it's not smoke because it's not smoke because the thing is not burning. But yeah, this water is now in this vapor form, and the advantage of this is that apparently it soaks up the heat from within whatever area you release this vapor into. And supposedly this helps cool an area because the water droplets, the minuscule water droplets in the vapor, they evaporate because of the heat, and that's essentially cooling down the area, or at the very least, it's preventing the area from becoming hotter. I don't know about cooling it down, but it's preventing it from becoming hotter. So I guess in that aspect, yeah, it does cool it down. We have summer approaching here, and where I live, summer gets insanely hot. It gets crazy hot. It gets so hot that half of my, so I do gardening as a hobby, and in my balcony I have a bunch of plants. Half of my plants die, depending on which, breed it is, which specific species it is. Half of them die out. Actually, a good like 75% die out. There's very specific plants um, that I have to grow if I wanna be able to do gardening during summer, and that's because of the heat. So that's what I'm trying to combat here. I'm trying to reduce the heat in that area, and what I want to do is I want to use these misting modules, these atomizer modules to actually it's one module, and it's going to be connected to four different atomizers. And what I want to do is I want to set up a system that um, every hour, I guess, it releases this vapor kind of thing. I'll have to see how to go about setting up the reservoir for this thing. Um, I have to see how much of the water it consumes and various other things. But I want to start by setting up a small thing, and then later on, if it works out, if it works out well, later on I can expand it. I could have maybe two. Um, I could have two of these things controlled by one ESP32, two separate modules, two separate reservoirs. I'll have to work on the wiring. That would be an interesting project, though. Um, Trying to expand this, because something that I need to keep in mind, and like this is one of those things, like this is one of those things that like I wouldn't have thought of this myself, that this could be a problem. Uh, but like when I talk to Gemini about it, Gemini tells me that, oh yeah, here's a warning. This is one of the things that could go wrong. So what I'm talking about is like, okay, when I share the positives of the ESP32 and the atomizer modules, um, the plus, so the positive voltage from one, is there a chance that it could go to the other module? Like, is there something that can go wrong there? I need to talk to Gemini about this and see if there's something I need to look into here. But yeah, that would be a good expansion. I'm pretty sure because okay, another interesting thing is that these atomizer modules, they're 5-volt modules, so you only need a phone charger to power them. In fact, let me look up what their actual power or their actual current, what their actual current draw is. I should probably also look into the power as well, but like, yeah, let's see what their current draw is. There's also the fact that like I'm only it's these are meant to be what do you call like the one-off things? Like they're meant to be run in bursts. So basically I'm saying every hour of the day, or well, I can add in a um I can add in a light dependent. What is it? Light determined resistor, or was it okay? LDR resistor. Light dependent. Okay, I can add in a light dependent resistor and detect light. I also have something else that can detect the light. I just remembered that. Um, there's a separate module that can detect light, so I can probably use that as well if I need to. And then that way, at night or once the sun goes down, we don't use up we don't do any of the vapor stuff anymore. And additionally, I want to see how well it works out if I attach a power bank to this. I feel like one major hurdle that I'm gonna have there is that I want to keep the entire setup as relatively cool as possible. And the fact that this thing is going to be outside to begin with means it's like the entire area could get hot. That hardware could get hot. Not because it is working, but because it's just hot outside. Everything gets heated up, especially during like midday. it gets crazy hot outside. So being able to cool down the area with um, even with this vapor, it would help. Yeah, I definitely want to experiment with this. Let me add it to my list. SD card reader, modular breadboard, force sensitive resistors, assorted trim parts. Okay, this list is starting to become a little bit long. Um, ultrasonic atomizer module. I'll only order one. I don't want to order multiple. I'll order one. I'll test that out and see how things work out. Or I could order multiple because what I'm ordering is one atomizer module that can that accepts connections from four different um, atomizers. So I can connect four different atomizers into it. And what I could do is, for the sake of being able to, um, for the sake of being able to test and debug and stuff, I could instead order 2x2s. Let me see how expensive the thing is. But yeah, that's another thing I'm going to be using the optocouplers with. I was initially a little bit concerned that I might need to use a transistor in there as well, because I wasn't sure. Because like some of these atomizer modules, they come with like modes. So you press the button once, and it switches on, and it's in one mode, which is like, you know, I don't know. Let's say um, uh, puffing out vapor every I don't know, it gives out puffs every 30 seconds, let's say, for example. Another one could be, and these are like rapid puffs. They're not long puffs. Another mode could be that it gives long puffs every, 15 seconds or something like that. Different modes, different ways of operating. What I want is just one mode. And fortunately, the specific module that I found, the seller has mentioned that on the back of it there are two contact pads. If you just short them together, then you don't need to use the button anymore. If you just short them together, it's going to run constantly. So what I could do is, um, in order to short it, I could use an optocoupler, and that way I can control it using the the microcontroller. So my one of my concerns there was, what about current? Is there going to be a lot of current passing through this? But fortunately, these modules usually have tiny microcontrollers within them, and the button is talking to the microcontroller, not directly to the high power, high current hardware. So I should be able to just, throw an opto in there and control it using a microcontroller. I will definitely need to use my breadboard. My breadboard. Hold up. USB breakout board. That's the term I was looking for. I will definitely need to use a USB breakout board. This is basically just a USB. It's a small board with a USB port and four pins. So the port expands into those four pins. Two of those pins are plus and minus, and two of them are data plus and minus. So all I'm going to be using is the plus and minus. And actually, I need to confirm that the I've got the pin structure right. I could be wrong about the pin structure. I don't think I'm wrong about it though. I don't think I'm wrong about it though. Um, because yes, you do need power, but you also need the data lines. So if there are only four, I think it makes sense to assume that one of them is VCC, another is ground, and then two of them are data plus and minus. But still, I'll check. Anyways, so that's a USB breakout board. And through that, I can kind of split the connection of a USB power source into multiple different devices if I need to. My concern there when I'm splitting is the current from one thing going to another. So I need to look into that. Uh, at some point, I might also need to join their grounds. So I'm a little bit nervous about that as well. I'll have to I'll have to see how to go about that in a safe manner. Because another thing I could do is I could just control the microcontroller and um, the atomizer modules with separate power sources. They don't have to be controlled by the same power source. That's another option, and that option definitely works, especially if I'm using an optocoupler. That option absolutely works. So I can have two power sources there. Um, the ESP32 can be connected to a power bank, and the atomizer module can be connected to like a phone charger or something, and we are good to go. I would like to share their sources though. If it's, I'll have to see. I'll have to see. I would definitely like to share their sources though. In this case, it should be a little simpler to do that. I feel like because while the current is not the same, the voltage is going to be the same. So I need to make sure that the current that's running through the high power circuit, which is the atomizer circuit, it's not, somehow ending up in the ESP32 circuit. I need to do research surrounding that to try and understand like what's going on there. Um, but yeah, I have that project in mind as well. I'm going to be working on that. Um, there was another question I'd asked Gemini about. Oh, wait, let me. So there's a shortcut. No, there's a short circuit. Okay. Okay, when you look at the back of the board, so and so, so and so, so and so. Okay, there's another thing I'm a bit concerned about. I want to try and power both the ESP32 and the module from the same 5V source using a USB breakout board. Um, this means this means that the two VCCs and GNDs will the two VCCs and two GNDs will be um no let me okay the two VCCs will be joined. The two VCCs of um, each device will be joined, and so will the two GNDs. This has me concerned because while they are same voltage, they are definitely not the same current. Explain to me how the current is going to be flowing there, flowing in this situation, and if there are any precautions I need to take. Okay, this is one of the most common points of confusion when starting out with electronics. The good news is that current, amps, is pulled, not pushed. Think of your 5V power source like a water tower, um, and your devices. And your devices, and your device, oh my God, words. And your devices like faucets. Even if the tower can provide 100 gallons per minute, if you only open a small sink faucet, like the ESP32, only a small amount of water flows. Opening the shower, that's the mister, doesn't force extra water into the sink. They both just take what they need from the same pressurized supply. The current math, when you join the VCCs and GNDs, you are creating a parallel circuit. I did not think about that. Yes, that is true. We are creating a parallel circuit. In parallel circuits, the voltage stays the same, but the total current required is the sum of all parts. The ESP32 draws 100 milliamps to 250 milliamps. It spikes when Wi-Fi is active. The MR module draws 500 milliamps to 300 milliamps to 500 milliamps. I was expecting it to be a bit higher, honestly. And that is while it's atomizing. It draws 300 to 500. The total load is 400 milliamps to 750 milliamps. The precaution, you must ensure your USB power brick or the wall wart is rated for at least 1 amp or 2 amps. If your power source is only 500 milliamps, like an old computer USB 2.0 port, the voltage will sag when the mister turns on, causing the ESP32 to brown out and crash. The real concern is electrical noise. While the current won't blow up the ESP32, the mister is a noisy neighbor. Because the mister uses high frequency switching, the 110 kilohertz vibration we discussed, it creates tiny ripples or noise on the power lines. Since your ESP32 is sharing those power lines, this noise can sometimes interfere with the ESP32's sensitive Wi Fi radio or cause it to reset. The fix, the decoupling trick. To keep the ESP32 happy, you should add a capacitor across the power lines as close as possible to the ESP32, or as close to the ESP32 as possible. What to use? An electrolytic capacitor between 5 volts and ground. You know, this is this I've seen this thing occurring often. This the need for a capacitor across the lines. And I would definitely like to get into this. I would like to study this once we start doing more analog electronics stuff, which we will get to that once we have learned the basics. Sorry, once we have learned the basics of dealing with microcontrollers using no STD Rust, and once we've also learned how microcontrollers work, because that analog electronics course that I've set up through Gemini, it is being set up with the assumption that I know how um, microcontrollers work, and I kind of know how microcontrollers work, not fully. Okay, what was I saying? Sorry, zoned out. Okay. What to use? An electrolytic capacitor between 5 volts and ground. What it does, it acts like a tiny local battery. If the mister creates a sudden dip in power, the capacitor fills the gap instantly so the ESP32 never feels it. Why the optocoupler is still your hero? By using the optocoupler, you have successfully separated the logic, which is the brain signals, even though they share the power, which is the food. Okay, yeah, I wasn't thinking about that. Yep, yep. I wasn't thinking about that because it's kind of like, okay, if we are anyways sharing the power, are we not combining the circuits anyways? I should do research on that. I should do research on that. I'm wondering if I should open up a new conversation with Gemini. I'm probably going to rename today's stream because we are probably not going to be discussing any of the clock stuff today. I guess I'll just rename it to talking about my various electronics projects because that's basically what I'm doing right now. Okay, if you had used a transistor instead of an opto, any electrical noise from the mistor's high frequency circuit could travel through the transistor's gate. Oh, see, I didn't consider that. So what Gemini is saying is, if you had used a transistor instead of an opto, any electrical noise from the mistor's high frequency circuit could travel through the transistor's gate right into the ESP32's GPIO pin. The optocoupler blocks this entirely. Okay, okay, all right. So now you have me curious because I'm wondering, aren't we um, currently discussing doing what I was concerned with earlier, um, combining circuits? Or is this not technically combining because we are only sharing the power? Because I feel like um, combining the grounds is combining the circuits. No? Um, what else? What else? I also had no idea about that the possibility that that noise could travel back through the transistor into the GPIO pin. Through the transistor at all. Let's say that. Let's talk about all this in more detail. Now, while Gemini gives this answer, which is only going to be a few seconds later, I'm gonna tell you guys about some of the other stuff that I was discussing with Gemini. One of the things that I'm very interested in checking out today, I saw this post on Twitter, X, um, of somebody talking about a crystal that they grew, and I've never looked too much into crystals, um, or rather, I should say, buying crystals has never really been a thing of interest for me. But like, I think they look great, at least naturally formed ones. And I say naturally because, I mean, okay, sorry. While I say naturally, I still have no idea how they're made, how they're formed. And so like, I've always had like a certain amount of curiosity there, certain amount of interest in understanding how these crystals are made. And I saw this one person had posted this crystal thing, and their entire account is just making crystals, making crystals. Like so this person, I'm assuming they have a certain amount of, if not like a crazy amount of chemistry knowledge, and so they know that they can combine various types of chemicals together and then create crystals out of them. But what I was interested in was the concept of creating crystals. I was like, okay, how is this whole thing working? And can I like just grow them at home? Turns out, yeah, you can. And what you're going to make, it depends on what ingredients you're using, and you can use a bunch of different ingredients. So I'm interested in trying that out. I want to see what stuff I can come up with, because crystals, they're one of those things that you set the thing up and then you just leave it. So you have to leave it somewhere, leave it alone for the next how many ever weeks, and then come back to it to see the result. And the longer you leave it, the more growth, quote unquote, there's going to be. And I'm interested in finding out how this whole growth thing is working, really. Like what's going on there? What's the controlling, what are the controlling factors there? What are the variables there? Um, so I might be looking into growing crystals at some point. But okay, Gemini has responded to my question. Okay, this is the perfect light bulb moment in electronics. You have hit on the exact distinction between power rails and signal paths. To your point, yes, you are technically, quote unquote, combining them at the power source, but you are keeping their nervous systems isolated. Okay, the nervous systems is the signals. Is sharing ground combining? In electronics, ground is a common reference point. It's the floor of a building. Every circuit, what? Reference point. Okay, it's the floor of a building. Every circuit needs to stand on the floor to work. With sharing power, this is like two different people, the ESP32 and the Mister, eating from the same giant bowl of soup. Okay, analogy time. They are connected to the food source, but they aren't the same person. Sharing signals. This is like those two people trying to share the same brain. This is where things get combined in a way that can be dangerous. When people talk about the dangers of combining circuits, they usually mean connecting a high voltage signal, like a 60-volt burst, going to that atomizer disk directly to a low voltage pin on a microcontroller. The transistor versus the optocoupler. Um, you were surprised that noise could travel through a transistor. Here's why that happens. The transistor, a transistor like a MOSFET, is a physical piece of silicon. To make to make it work, the ESP32 must send a voltage to the gate. To complete that circuit, the ESP32's ground and the Mister ground must be tied together right at the transistor. The risk, because this is a physical connection, high frequency spikes from the Mister can leak across the silicon and travel back up the wire into the ESP32's brain. It's like having a door between two rooms. Even if it's closed, sound, which is noise, can still vibrate through the wood. All right, the optocoupler. Inside an optocoupler, there's no metal. Yeah, okay, I know about the isolation in an optocoupler. The ground loop and electrical noise. Even if you use an optocoupler, because you are sharing the same USB power supply, you have created what is called a common ground. The quote unquote noise we talked about travels along the ground wire. Imagine the Mister is stomping on the floor 110,000 times a second. The ESP32 is standing on the same floor and might feel those vibrations. Okay, okay, I'm getting it. The analogy is helping here. Why it usually doesn't break things. Digital chips are pretty tough. A little vibration on the ground won't usually fry the chip, but it might make the Wi-Fi drop its connection or cause the code to hiccup and restart. The solution, the capacitor. As mentioned, the capacitor acts like a shock absorber for these floor vibrations. It keeps the floor steady for the ESP32 while the Mister is stomping. I still didn't understand how the capacitor is handling the noise, because these are two different things we are talking about, right? We're talking about noise being generated by this higher power circuit. We're talking about like the noise bleeding from one high power circuit to another. But then when we're talking about the capacitor being thrown in there, we are giving the explanation that, oh yeah, if there's a sudden power, if there's like a sudden power burst kind of thing, like if the high power circuit suddenly pulls a lot of power, then the capacitor can sort of pitch in and compensate for whatever is missing, and that way the ESP32 won't experience a hiccup. So I don't really understand how the two are connected. But I do know that yes, capacitors are used for these kinds of situations and to kind of smooth out the noise. I don't fully understand what that means here, but I understand that it's getting rid of the noise somehow. Conceptually, that's what's happening, but in reality, what's happening, I need to figure that out. Hold on just a second here. Okay, but aren't there still any risks associated with sharing sharing uh, GNDs? I feel like some of them would still apply here. No? Then another question. Okay, I also haven't really understood um, the capacitor thing because you mentioned that if the high power circuit requires or well has a sudden heavy need for current, um, the capacitor can compensate, thereby leaving the ESP32 unaffected. I don't understand how this is helping smooth out the noise um, generated by the high power circuit. Okay, you have a very sharp intuition for the gotchas of electronics. You're asking the exact questions that separate a hobby. Okay, thank you. Appreciate it. Now let's get into the information. Let's break down the ground risks and capacitor's dual role. The shock absorber versus the filter. Okay, the risks of sharing ground. The ground loop myth versus reality. In a simple USB powered project, sharing a ground is usually mandatory, but there are two real risks you should know about. The ground offset, which is the voltage drop. If the wire connecting your mister to the USB breakout is very thin, and the, and the mister pulls a lot of current, the resistance of that wire actually turns into a tiny heater. Actually turns it into a tiny heater. This causes the ground at the mister to be at a slightly higher voltage than the ground at the USB plug. Oh, that's interesting. Okay, the risk. If you weren't using an optocoupler, this shifted ground could confuse the ESP32's signals. Okay. Wait, I'm a bit confused about that. Okay, the opto wins. Since the optocoupler doesn't care about the ground reference on the other side, this risk is nullified. Oh, so this would have been in case if I was using a transistor, because then the transistor is also connected to the ground, right? It's connected to the shared ground. Yeah, okay. Then the inductive kickback. When the mistor turns off suddenly, the magnetic field in in its inductor, which is the that yellow ring, collapses. This can send a jolt back to the ground wire. The risk, this jolt can travel up the ground wire to the ESP32. The fix, this is where the capacitor comes in. The capacitor helps with that jolt as well. I thought Gemini was about to mention a diode in here. Okay, so moving on to the next section, because that last sentence leads right to the next section. How the capacitor smooths the noise. You understood the local battery part, which is preventing brownouts, but here's how it handles the high frequency noise you're worried about. Nah, dude, hold on. I'm still concerned about this right now because, yeah, I'm still concerned about this. For the sake of my sanity, I would definitely like to give this give them two separate power sources, at least until I'm comfortable with them sharing ground. Yeah, at least until I'm comfortable with them sharing ground, I would like to give them two separate power sources. Yeah, yeah, definitely. That would be a bit of a messy setup though, if I'm being honest. And having two separate power sources is kind of it's very inconvenient. One of them is going to have to be the power bank for sure. Sorry, zoned out. Okay. In electronics, noise is just very fast, tiny changes in voltage. DC power, good. A flat, calm lake. Noise, bad. Tiny, jagged ripples on the surface of that lake. A capacitor is physically built to resist changes in voltage. When a high voltage ripple, such as noise, tries to pass by, the capacitor sucks it up because it's thirsty for charge. When a low voltage dip tries to pass by, the capacitor squeezes a little bit of its stored energy back out. Oh, that's interesting. Wait, that's crazy. So the capacitor can absorb whatever extra charge is coming through, thereby smoothing out the signal and also charging the capacitor. So that the next time there's a need for some sort of distribution, it uses that charge. That's crazy, dude. I didn't know that's the thing. I guess this is where analog electronics knowledge would help. Okay, the result. The jagged ripples get absorbed by the capacitor because before they reach the ESP32. On an oscilloscope, you would see the messy, noisy line from the mister become a smooth, flat line after the capacitor. Then, the ground path strategy. To make this as safe as possible with with your shared USB breakout, follow the star ground principle. Instead of daisy chaining, uh, doing USB to Mister to ESP32, I wasn't planning on doing that. I probably should have mentioned this. Yeah, I wasn't planning on chaining them in that way. I was planning on going from the USB breakout board to so basically forking it. I was planning on forking the connection, splitting up VCC into two parts and splitting up ground into two parts. Um, I thought that was obvious when Gemini mentioned them being in parallel because forking the connections does cause them to be in parallel, right? I thought that was understood here. Okay, anyways, Follow the star ground principle. Instead of daisy chaining, um, connect them like a star. Run one pair of 5-volt and ground wires from the USB breakout board to the mister, and run a separate pair of 5-volt and ground wires from the USB breakout to the so and so, and then place, oh well, from the breakout board to the ESP32, and then place the capacitor right at the ESP32's feet, the 5-volt and ground pins. Okay, okay, all right. Why do this? By giving them separate roads back to the main gate, which is the USB plug, the noise generated by the mister has to travel all the way back to the USB plug before it can try to turn around and go towards the ESP32. Most of that noise will be eaten by the power supply or that capacitor it's complete, before it complete that U-turn. Okay, okay, all right. You know what? That's satisfactory for me for now. I do want to continue this conversation with Gemini. I'm not fully convinced about this, or I'm not fully satisfied with my knowledge or lack thereof, of sharing grounds together. Yeah, yeah. I'm still not entirely satisfied with what I do and don't know about this. And so before I connect these two things together, I would definitely like to understand what I'm doing. See, another thing that I could do is I could start using lithium ion batteries to power my ESP32. And that way I can set up a small chargeable circuit kind of thing, solely for the ESP32. Um, and I would be able to, easily stick them to, whatever other thing. I don't need to worry too much about powering them from the same thing that I'm powering. From I wouldn't have to worry about having to power them using the same thing that I'm using to power the circuit that I'm going to be controlling with the ESP32. Yeah, yeah, no, I need to do more research here. I guess I can have a conversation with Gemini about like all the details surrounding um having two separate grounds. Yeah, yeah, I can do that. I can do that. Definitely. All right. You know what? Um, Give me a second here. I'm just looking. You know what? Hold on. Let me see if I'm actually able to jump into this person's stream. Yes. Seems like I can. Now let me see if I'm able to start up the raid. Make sure they don't have any settings that prevent a raid. No, we're good. We're good. You know what? Okay, so we're gonna be ending things here. That's gonna be it for today's stream. I do need to remember to rename or retitle the stream to just talking about my electronics projects or whatever. And yeah, unfortunately, I started the stream a little bit late today, and so I wasn't able to stream for too long. Hopefully, I'll start earlier tomorrow, and then, you know, I can stream for much longer because the past 2 or 3 days we have been streaming for a good like 2.5 hours, which is great. But yeah, dude. Um, yeah, I need to do more of this research because up until today's stream, I hadn't even thought about this thing that I would have to share the ground between these two. Which, to be fair, I only started thinking about the circuit yesterday. So, but yeah, I need to do the research on that whole sharing ground thing. I do want to maintain isolation as much as possible. Um, just for safety reasons and just so I'm comfortable. Anyways, okay, the time is running out. That's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.